Alrighty, so here's section 2.3, proof of the product rule. And so, we want to look at the limit as h goes to 0 of f of x plus h times g of x plus h minus f of x g of x, all divided by h. Well, the little thing we can do here is add 0 in the numerator. So that's the nifty little algebra ploy that we use. And so what I can do is I can subtract out f of x plus h times g of x, add that back in, f of x plus h times g of x, and so I've added 0, and we're running out of room, but I think I can maybe get it in here, g of x, all divided by h. And then what we do is we simply regroup, and then, of course, assuming the limits exist, we can break them up. And so we have the limit as h goes to 0 of, and I'll just keep them in the order they're in. So f of x plus h, g of x plus h, minus f of x, plus h, g of x. So that's that first part divided by h. And then add in the second part. So I'm going to come down here a little bit and do plus the limit as h goes to 0 of that second part. So f of x plus h, g of x, minus f of x, g of x, all divided by h. And so then, I can factor out, in this first case, the f of x plus h. That's in both of those. So this is the limit as h goes to 0 of f of x plus h times g of x plus h minus g of x all over h, and then plus, now in this case I can factor out the g of x here, and actually that doesn't have an h in it, so I can pull that clear out of the limit if I wish. So the limit as h goes to 0 of f of x plus h minus f of x all over h. And so then you see, oops, that should be a square bracket. So here, the first part, as the limit as h goes to 0 of f of x plus h, that's just going to be f of x. And then, because we assume f of x is a nice continuous function, and then the second part, well, that's just the definition of the derivative. And so, as limit as h goes to 0, we just get f of x times g prime of x, and then plus, here we have the g of x, and that part is just the derivative of f, so f prime of x. And so that's where we get our product rule. And is just, we take our limit of that difference quotient up here, because that's our definition of our derivative of our product, and play a little algebra magic, and we end up with our product rule. So there's our derivation of the product rule.